All the problems in the world.
I would try to do.
Yeah.
Yeah.
Wait, you should do this.
I'll do a quick intro and
Build
yes,
a model.
Oh, perfect.
all right.
You solver.
Welcome everybody to the MEM Seminar Series.
Yeah.
Our topic today is life cycle analysis, and as I was mentioning earlier, I think this is particularly important for product managers, aspiring product managers, because the products of the future, frankly, I'm not so concerned about user centricity or technology centricity. I'm worried about keeping the planet in our centered vision here, right? In terms of circular economy and reducing our impact on our footprint. Because if we don't start thinking this way and acting this way and designing products this way, we're dooming ourselves. Not so much the planet, but ourselves, right? Because the planet can survive a lot of things. We can't. We're nowhere near as resilient as we think we are, right? And we'll find that out, I fear, in the next few years. But in anticipation, I guess let's turn it over to what I'm calling the Jennifer Dunn Lab, which is really Chase, Jenna, and Maggie. These are graduate students that work for Jennifer Dunn. Jennifer Dunn, in my mind, is kind of a pioneer of sorts when it comes to LCA. She's given talks around the world, and she's a world-renowned speaker. These folks have studied under her and know it inside and out, and she referred us to them. So let's let them take it away. Thank you.
So hey everyone, my name is Chase Lavlis. I'm a third-year PhD candidate. I'm Jennifer Dunn, the group, guys.
I'm Jenna. I'm a second-year doctoral student in Jennifer's lab. And I'm Maggie. I'm also a third-year PhD candidate.
Yeah, and we're really excited to talk to you guys today about just life cycle assessments and this overall field and methodology. So we're going to talk about a little bit about what life cycle assessments are and why they're important. We'll go through some of the steps of how you will complete one, and then talk a little bit about some other emerging areas that are becoming more relevant in the life cycle assessment space. So first, just what is a life cycle assessment? And it's really just a methodology that people are using to try and get an understanding of what type of environmental impacts a particular product, a particular process, particular technology might be having in society, and then being able to then compare those impacts to other technologies, other processes that are doing the same thing. So there's a pretty industrial standard of what this process looks like called ISO. And really you can really look at from a material, from taking all the raw materials out of the ground all the way through its end of use phase, trying to figure out how you're going to dispose it. And, really taking into account what each of those steps taking place, how those impacts, various impacts of the environment. And, the importance of doing an LCA and why it's important is because, you want to be able to understand, if you're trying to develop a new technology, how does it impact, what that impact is, so you can, go to a manager, go to a policymaker, and try and pitch, well, this technology, this method, this new process is important because now we're doing something that's now 10% lower GHG emissions, or emits 20% less, pollution or type of nitrates and stuff into water systems. And that really helps people really understand how to implement these technologies, and as well as just really develop better technologies as a whole. And the other really good thing about it is it really gives you an idea of how you can compare different products, right? So if you're trying to figure out, what type of meals have the least impact on the environment, or if it's, the big one now is, electric cars versus fossil fuel cars, how you do compare holistically and fairly the impact of an electric car versus a fossil fuel car. And this life cycle assessment and this methodology really gives you a framework to really be able to understand what those impacts are comparatively between these different technologies and these different systems. And the other thing that's interesting about life cycle assessment is, the combination of you might not always, what you think is really the most sustainable solution sometimes actually isn't the most sustainable solution. Combined with you can actually apply this to things that you might not necessarily think about, and really get an understanding of what that life cycle and greenhouse impact is. So here's an example of just someone doing a life cycle assessment, comparing, those type of a meal kit, so kind of thing like a HelloFresh or something like that, versus, going to Jewel Osco and going to get a pre-prepared meal. And, it's not something when you might initially think about life cycle assessments or like your impact, at a consumer level, you might not think about how your day-to-day decisions are really having a major effect on, on type of environmental sustainability and your impact on the globe. So interestingly, this study basically looked at these two potential supply chains. So looking at the different steps in the supply chain of getting a meal kit, so getting some HelloFresh from all the different products all the way to your door versus going to the grocery, similar process of going all the steps of going to the grocery store, and then you go into the store and buying the product yourself, and then taking it to your home for eating it. And it's interesting to see because it takes things that there's the extra transportation, the additional transportation from getting the distributor to your house versus going to the store first, then going to your house. Does that have a potential impact on the overall sustainability, or the difference in the amount of packaging that you might use in a home meal kit versus going to a store-bought kit? And what does that look like? And interestingly enough, you can see is that, at the bottom graph, the graph on the bottom right is that for the most part, the grocery store kits do better. And you can see it's kind of dramatically different sometimes, so the salmon case, there's not a little bit of a difference, but maybe about 2 or 3 kilograms of CO2. But if you look at the pasta version, there's a lot more emissions that come with going to the grocery store and buying a pasta-based meal kit versus going and buying one from HelloFresh or something. So it's really interesting to see just because how there's a potential of a wide variety of impacts that, even just small steps in the entire life cycle chain could really have on the overall sustainability of the product. And doing life cycle assessments really gives you an idea and to really investigate and really see what those impacts are and which steps have the biggest impact, so then you can then change them. And finally, when we talk about LCA, it's also interesting because LCA is part of this idea of sustainability. And when a lot of people think about sustainability, you think about obviously the environmental impacts, but sustainability is really all-encompassing. There's a lot of things that take into account into sustainability. So not just the environmental impacts, but what are the social impacts of a technology or a tool? It's having, maybe has a little bit of a better environmental impact, but the way that you get the materials that you need for are negatively impacting specific communities. So, they have tools and methodologies that are now being developed for that, which we'll talk about a little bit later. And then another tool called techno-economic assessment, which is similar to LCA in terms of methodology, but looking at what the economic impacts of something. So how does a new technology, a new process, potentially impact not just the production of the economic cost of producing the product, but how much it costs to consume it, how much does it cost to dispose of it versus traditional pathways and things like that. So it's really important when you think about sustainability, all 3 of these areas are really important to really try and think about when trying to understand how can you make a technology or make something more sustainable. And then, so next we're just going to talk about the steps. So typically when you do an LCA, there's 4 steps. So the first step is, defining what your goal of it's going to be. The next being, trying to gather the data for what data are you going to need for completing the life cycle assessment. The impacts. So what impact categories or what environmental impacts are you concerned about in terms of specifically for a specific tool technology? And then finally, interpretation, which is how do you understand and how do you understand what the results look like? How do you convey those results to the parties that are interested in them? So we're going to go through each of these steps. So first, starting with the goal and definition, but it's kind of the first step, but it's really arguably the most important step because all of your everything you do after this step is really going to be based on how you define the goal, how you define what you're looking for. And, there's really 3 or 4 sections that you're really trying to think about whenever you're trying to define what your goal of your LCA is. So first, obviously what are you trying to accomplish? What is the product they're trying to understand? What's the, why are you doing the LCA? Who are you conveying the results to? Are you giving it to a policymaker versus are you giving it to a technology person versus giving it to a consumer? And then other things that are important to think about is basically something called the functional unit. So what's the reference point that you're going to be comparing these different tools and systems to? The system boundary, which is what area, what section of the life cycle are you considering? And then how are you evaluating it and how are you considering the environmental impacts of it? So we'll go through some of these terms. We just do a lot of terms at you, but we'll go through each of these terms a little more in detail. So just here's a few examples of what potential goals of what your LCA could be. You could be doing an LCA because there's a new policy, like for instance in California, they're trying to make it so that electrical cars can only be sold by 2030. So what would be the impact if you had cars sold by 2030? What's the environmental impact of that, and how do you develop policy that further implements and progresses that being forward? Or how, if you don't have a technology, a brand new technology that maybe someone is developing in a lab, what does that technology potential impact look like? So you can do an LCA even at a small scale and figure out, what's the environmental impacts, what are the potential impacts, what could it be, are there specific steps in the process that you're developing that are much more damaging than other steps that you might want to further reevaluate, just really get an idea of what those broad environmental impacts of these two technologies and things could be. And then further going along the line, being able to get ideas of product development as you're developing a different product, how you're trying to decide and relay information to different interested parties, or even some people have product certifications, like this, like whatever the green building certification stuff is. There's people that do LCAs on a building, be able to prove, this building produces this amount of GHG emissions. It has, this is below the whatever the requirement is to get the certification. So now you can have that building green certified.
So is that like LEED,
Mhm.
the LEED certification?
Mhm. I was like, I couldn't remember what the acronym was. I was like,
LEED.
so I appreciate it.
The Ford building is, I think, LEED Platinum or.
I believe so. So the next thing is what's called the functional unit. So functional unit is basically how you're what you're basing the evaluation off of. So it's important whenever you do a life cycle assessment that you're comparing apples to apples, right? Like you don't, if you're comparing things that are not on the same scale, not on the same terminology, then the comparison will not be accurate, because the evaluation might favor one technology over the other. So no, it's just to make sure, like a way you basically define a term that you can basically be broad enough where it captures everything, broad enough in order to, you can compare a new technology to maybe other existing technologies, and something that you can measure and quantify. So here are a couple of examples and stuff that we've worked on in our group. So here is kind of one that might not be a good one. Those, if you're developing a catalyst for production of a new product, or for in this case phenol, if you just said, 1 ton of catalyst is your functional unit, right? Something like a catalyst might have different catalysts might have different properties. They might have different characterizations. There are different methods of making them. So as a result, it might not be a fair comparison, because if even using the same amount of 2 catalysts, one might produce a lot more of a product than another. So instead, you want to be able to make your functional unit so it's something that's quantifiable, and you've been able to more easily compare things with each other. So instead of just saying, 1 ton of catalyst, you could say a ton of the amount of catalyst in tons to be able to produce X amount of phenol in this case, but any specific material that you were looking into. And another example that we use in our group, which is another important thing to kind of think about, is when you're developing a technology, when you're developing a process, trying to understand, do you care more about the input of the process or the output of the process, right? So another one, if we look at like wastewater treatment, you might care, maybe you're comparing wastewater treatment plants to wastewater treatment plant. So then as a result, you want to compare them both to the amount of wastewater that they're treating. So in that case, you would use a certain amount of wastewater being treated as the comparison point. Or maybe instead of you caring more about the wastewater being treated, you care more about recovering nutrients or recovering a particular product from that system. You can then say, instead of using a functional unit per mass of wastewater, per volume of wastewater, you could do per mass of nutrient recovered, what then allows you to compare different technologies in that same system against each other. And then next go system boundaries. So system boundary is just basically the area that you're trying to compare, and like what part of the life cycle of the product that you're interested in evaluating. It's important that whatever the system boundary is supported by what output, what outcome of the LCA that you want. And there's a little bit of things that you need to consider when you're trying to understand what type of way you want the system boundary to be. And so just some specific terminology. So just the difference between, you'll hear people say foreground or background, which is basically, if you're considering the electricity that's going into a system, that might be the background product, background process, versus if you're, actual inputs and outputs of a system might be a foreground process. And then you have specific terms called like cradle to grave, which is basically if you want to start the raw materials of a product all the way to its end of life. If you want to get gate to gate, which is maybe just, transporting to processing, you only want to care about, or cradle to cradle, they mentioned circularity. So maybe you take a waste product that typically would go into a waste stream and then figure out how do you use that as an input for whatever process that you're considering. So here's just a broad diagram of what your system boundary will look like. So, you have your energy inputs, you have your raw material inputs, draw a box about which steps that you are most interested in. And then you get these various outputs that you would then use further down the line to try and understand what the life cycle impacts.
Sorry,
And-
can we go to the last slide?
Yes.
Last than that. Can you give an example of cradle to cradle?
Yeah, so in our group, we do a lot of, for instance, like nutrient recovery. So like taking something like waste nitrogen. So a lot of, for instance, fertilizer is a very big product that gets used for growing crops and growing, anything that goes into food. But a lot of that nitrogen doesn't end up in the crops and stuff itself. It ends up into the environment as a waste. So we do stuff in our group where basically instead of that being a waste, how do you recover that nitrogen that would typically go into the environment and be a pollutant, recapture it, and then use that as another input for chemical, for whatever, producing fertilizer for other chemical production.
So it's not an input to Haber-Bosch per se, right?
Mhm.
It'll be an input to some other process.
Exactly.
Okay.
So another common example is like plastic recycling. So how if you recover plastic from a landfill and then you basically recover the plastic and are able to make it basically pure enough again where you can input it to now making water bottles or something and maintain most of the properties of it. Now you're foregoing all the steps of making the initial plastic, all the fossil fuels and stuff that you would initially need to make a water bottle, because you're able to just use waste plastics that's already available and transform it back into a water bottle.
On this slide, this to me looks like classic systems thinking, and it seems to me like LCA and systems thinking have a huge amount of overlap here, right? I mean, you really can't do LCA without doing systems thinking.
Oh, definitely not.
But we lost a lot of the systems thinking back in the 70s,
Mhm.
right? So you guys kind of resurrected it, but for a very specific purpose, right?
Mhm.
Okay.
So here's just a couple of examples that we'll go through real quickly. So like if you wanted to look at, a particular process, two different processes, but they both make the same product and both utilize the same raw materials, you wouldn't theoretically include the system boundary such that the raw materials and products are included, because they're ultimately going to have the same amount of impact. So then you would draw your system boundaries just specifically around the processes, so then you can understand, directly understand what the differences in terms of environmental impacts between the two processes are. So kind of similarly, if you have the same process with two sets of raw materials, you could draw a system boundary around the two raw materials specifically to try to understand, what all goes into making those raw materials, how are they gathered, how are they made, processed, and then compare those against each other. And then even similarly, like, if you have something that's end use, so if you have plastic, if you're going to send a plastic to a landfill versus sending a plastic to a furnace to use for energy recovery versus using plastic and potentially recovering it to use as a second input, what do those final impacts and what does that look like? And then finally, another important thing that's important to think about in doing life cycle assessment and thinking about these system boundaries is, sometimes you'll come to a point where you're coming up with a process or technology where there's more than one product, right? So for instance, what if you produce something that you would use as a fertilizer, but also that same process also produces energy that you would send to maybe a house or something. And if you're producing multiple products, how do you understand, where do you draw the boundary? How do you understand and compare the impacts of something that maybe has two products where a process that maybe only has one? So there's different methods of doing this. So there's different allocation methods, which you might be taking into account the difference in mass. You might take into the difference in market demand. So maybe you develop two products, but one product has a 10 times its market rate than something else. So maybe as a result, you allocate the impacts and burdens of the processes based off that. Or you can just kind of expand the system and expand your system boundaries such that all the demand and all the burden kind of goes onto one of the products, and then you then compare that to how a particular, another technology, another process that's similar.
So once you establish your goal and your scope, the next important part is getting your data. So how do you characterize and quantify your inputs and your outputs and all the materials that you go in, how much energy goes in, and also the stuff that you get out. So there's a lot of different potential data sources that you can look at. There's a lot of stuff on the internet, which is great. In terms of open or like LCA specific stuff, there's a database called the Open LCA, and then also Argonne National Laboratory produced the greenhouse gases, regulated emissions, and energy use and technologies, or the GREET model, which is open source, and it provides a lot of data on basically a lot of different products. So anything from energy to minerals to how much like petroleum or petrochemicals or plastics, or they even give like emissions for like if you were to have like a machinery piece, like how many emissions are released from that. You can also look at different government reports and databases. So if you want agricultural data, so if you want to look at like nutrition or soil, you can look at the US Department of Agriculture, or the United States Geological Survey has a lot of stuff on minerals. So you can look at production data, import data, just any numbers to help you like quantify the system that you previously established. You can look at scientific literature. So lots of people have already done the hard work for you. And so you can go type into Google Scholar, whatever process you're looking for, and see if you find anything there. And then process modeling. So there's some tools commonly used in chemical engineering. One of them is called HYSYS. So you can build this model of like if you were to design a plant. So if you're working for a company and they have a model that you're using to design certain things, you could use that information. But regardless of whatever data source or model that you use, it's really important that you transparently like show and represent your data, just so that it gives credibility to your work, but also reproducibility in case somebody wants to add on, say that you did LCA to a certain point and they want to take it one step further, so that they can just repeat your methods without going through the whole thing themselves. So here's
do you need special training to use GREET, for example?
I think I learned it in probably 20 minutes.
Okay.
And I really mean that. And this is like a snapshot from GREET. So it's downloadable on Argonne National Lab. If you like Google Argonne National Laboratory GREET, it's free to download. And basically the most important tables, at least for a lot of our work, are these summary tables. So it's summary of energy consumption and emissions. And here this one's related to molybdenum, but it could be related to diesel, it could be related to polypropylene, or basically wherever you want. They have, I would say, hundreds of these tables, and then you just control F and find what you want. But they give a lot of stuff of like primary mining of per ton of molybdenum sulfide. And so then you can figure out the total energy, how much of that was fossil fuels, how much of that was coal, how much of that was natural gas or petroleum. They tell you like how many gallons of water are consumed per ton of molybdenum sulfide production. And then they give a lot of emissions information. So like how many of all these different emissions are released, but probably I don't know if my mouse is here, but probably the main one is this bottom row, that's greenhouse gas emissions. And so they basically take like a weighted sum on how potent each greenhouse gas is and sum it together so that you can see like how detrimental stuff is.
Also, Argonne is they're like constantly updating GREET and trying to keep it up to date as different processes change for producing some of these things. And Jennifer, when she worked at Argonne, did a lot with GREET development. And from what she said, I think you can pretty much just email them if you're having trouble with it and be like, I'm trying to do this. Like, how do I do that in GREET? And like they're like part of their job is supporting users.
Yeah, they have lots of documentation. I think they have a new release every single year. And again, it's like free, open source, just Google it. But it gives like a lot of information that at least I use a lot of it in my research. So definitely a very useful tool. And then I briefly touched on like government reports or government agencies. So a lot of my work concerns around minerals and mineral sustainability. So I use the United States Geological Survey mineral commodity summaries a lot. And so these are two snapshots of cobalt and clay, and they just give me like production statistics. So how many tons are produced by country. So if I wanted to do an LCA of cobalt production in the US versus the Democratic Republic of Congo, I'm able to look at those input flows. And then for clays, they have like more statistics. So they have like different types of clays, and if you import it to the US and also exports out of the US. So there's just like a lot of information that floats around on the internet. And then literature, I think, is more useful for niche applications. So here's one of like energy demand and carbon footprint of cheddar cheese with energy recovery from cheese waste. So that those researchers looked at, how much energy it costs to make cheddar cheese and like how environmentally friendly it is. And then a policymaker or somebody else could look and say, hey, here's how we can cut some of those emissions. And then kind of like Chase was saying earlier, wastewater is a huge thing. So you could look in the literature on like emissions of wastewater, textiles, so clothes. There's a lot of things about fast fashion right now. And so you can look at like how many or like how many GHGs or how much water does it take to produce one t-shirt versus, I don't know, like going to the thrift store and getting a t-shirt there, or with solar cells and renewable energy. So basically the literature is for anything that like the government doesn't do.
So can you comment on like cotton versus polyester, or lithium ion versus lithium iron phosphate? I mean, are we going in the right direction with some of these new technologies?
I can talk a little bit more about the lithium ion battery versus lithium ion phosphate because that is my research. Lithium iron phosphate is more promising because it uses iron and phosphorus, which are much more readily available materials than manganese and cobalt, which are in these lithium ion batteries. Since it is still up and coming, it is tough to like say like long-term which one is the best. But currently, just due to the ease of extraction and recyclability of iron and phosphorus, LFPs or the lithium iron phosphate batteries are, they're looking pretty promising. But there is a lot of literature on like, cotton versus polyester. Should you go to the thrift store? Should you, like Chase mentioned earlier, should you have like, there's a LCA example of whether you should be fully vegetarian or if you eat beef, however many days a week. So it's pretty interesting to see like all these changes that people are doing to sustainability and how they reflect data-wise in the literature.
There's sodium ion that's coming down.
Yeah, so there's sodium ion battery, there's potassium ion battery. And so my research primarily looks at like the sustainability of extraction, so like how much energy it costs to extract these minerals. And the nice thing about like lithium, sodium, and potassium is that they're primarily in these brines. So you don't have to chisel into rock, which saves a lot of energy, but then also you have a lot of issues with biodiversity and environmental degradation if you're depleting water resources that animals or local people might be using.
But it looks like we're going in the right direction.
That's the hope, yeah.
I need some hope.
So much more like how you define it, like cotton. I don't remember what I had one professor talk about, like cotton versus polyester type thing, and it just depends on one. If you look at like greenhouse gas emissions, cotton does way better. If you look at water consumption, cotton does way worse. That's also going to depend. Like you would have to like add the study and be like, okay, for the polyester, they include the water consumption for like whatever process went into refining the fossil fuel that made the polyester. Like it's really study dependent a lot, which is hard because everyone wants the answer.
There is no really like definitive answer. I think it's whatever perspective you value most, either as a company or as a policymaker, or even as an individual. Like I want to reduce my carbon footprint, so I really care about greenhouse gas emissions, or I live in a water scarce area, so I really want to reduce my water consumption. So there's really no cut and dry.
But a pair of jeans has how many hundreds of gallons of water? I mean, a pair
So
of jeans.
many because of like the dye and Yeah,
That's
but
crazy.
hopefully if you wear them for, I don't know, they say you wash, I think the old saying is like you only wash your jeans when they can stand up in the corner by themselves. And then the third step of completing LCA is taking all this data and showing its impact with it. So there's lots of ways that we can measure impact. And just as a little bit of a reminder, the LCA inventory stage, it quantifies the inputs and outputs, and it gets that at that per functional unit or per basis unit. So like all that information on like how many minerals does the US like import or extract or export. Whereas life cycle impact assessment translates those flows or those material streams into impact. So like global warming potential, or if it releases like photochemical ozone degrading chemicals. And so here's just like a little bit of an overview of LCIA, which is life cycle impact assessment phase. So you select your impact categories and their indicators, which I'll get into a brief example in a minute. And then you assign like, you know, we're going to have this product or this flow be attributed to this impact category. And then you do some math, which is also widely available in the literature. And that's called characterization. And then you get your LCIA like impact. So there's a bunch of different models that have different impact assessment categories. So one is climate change, or more commonly global warming potential. You can look at ozone depletion, respiratory inorganics, the impacts on human toxicity or ecotoxicity, or terrestrial eutrophication, or how much land is used. There's a whole bunch of impact categories, but these are just a couple of the really popular models that you can input your data and they'll spit out, you know, the impacts on climate change or on human toxicity. And so here's like kind of the classification part of, you know, you pick out some of the impact categories you want to look at, but now you need to assign your inputs and outputs to these categories. So if you are looking at stratospheric ozone depletion, you might look at your carbon fluorochlorides. Yes, your CFCs, basically really bad chemicals that are related to
Fluorocarbons.
yes, chlorofluorocarbons. I was getting the carbon and the chloro back. And then, you know, if you look at a process that has high emissions of sulfur oxides or nitrogen oxides or hydrochloric acids, maybe you might want to look at acidification. So it really depends on like what your process is producing and the issues that you might have. But also the choice of these impact categories depend on the why of the study. So why are you analyzing it? Do you want to look at the impacts that a chemical has on like local wastewater, or sorry, not wastewater, on like local water systems? And then characterization, like how much do each result contribute to the impact category? And I think the easiest one to start with is global warming potential. So their basis is carbon dioxide, which has a factor of 1, but other greenhouse gases such as methane or those CFCs have equivalency factors that reflect their potency as a greenhouse gas. So we know methane is way more potent than carbon dioxide. So we're going to assign it a stronger value than just regular carbon dioxide. So here's just a table from the IPCC, which is a huge intergovernmental organization, but you can see like methane in 20 years is 84 times more potent than carbon dioxide in 20 years. And so you can do all this math for how, for whatever emissions that you have. And then this is just kind of like a basic formula that you get things into the equivalencies of carbon dioxide emissions. And again, we can go back to GREET. GREET gives us some of these numbers, and also GREET gives us, you know, methane emissions or NOx emissions, and then you can do these calculations. And then some of the impact categories that I mentioned it's not just like that's the end all be all. There's a lot of new focus on getting newer environmental impacts, so like biodiversity. So how do you measure biodiversity vulnerability? How do you look at loss of endemic or endangered species? or in terms of agriculture, like crop yield or crop quality. And then like on land, like soil quality and health, like how do various pollutants or emissions affect soil health, or for example, like deforestation, if you have to cut down a lot of trees to make paper, kind of what impacts do those have on the land.
Cool. And then, so the last step of life cycle analysis is interpretation, but it's a little misleading to think of it as a last step. You need to kind of be interpreting all throughout to check that, you don't want to complete your LCA and then realize that somewhere you went way off course and are way outside your goal and scope definition. So yeah, you're essentially trying to make sure that you have answered the question that you've set out to answer. You basically accumulated the data that you would need to answer that question. You've identified the right indicators relevant to that question. And then you need to figure out, based on your LCA, kind of, do you need to iterate, or are there assumptions that you made that you now need to go back and see what would happen if you had assumed something different? And from that, what kind of recommendations can you give? So something that LCA is really good at doing is identifying like what are the really key areas that, like, oh, if you improve this one thing here, it doesn't really make that big of a difference. But if you improve this little thing here, this makes a huge difference. So that is what our efforts should be focused on. So this kind of is a very detailed interpretation kind of like process. So first, just checking, have we completed our LCA? Have we identified all the different scenarios? It's kind of remarkable how exponentially fast the number of scenarios that you realize are relevant grow. So have you kind of fairly addressed all of them? Did you evaluate everything consistently? And that's going to have to do a lot with whatever functional unit you chose. And then again, this kind of sensitivity check. So with life cycle analysis, you can basically get a life cycle analysis to say whatever you want to say. And that's kind of like a dangerous amount of power to have, because you can just make assumptions that get you a result that you want. And so you need to really check those assumptions. For instance, Jennifer one time told me about a paper that had this really attention-grabbing headline because they said that wind energy is actually worse than coal. Like, we're better off burning coal than using wind. But if you dove into the assumptions that they made, they assumed that wherever you were building this wind farm, you were cutting down old growth forest. And therefore they counted those emissions as part of the wind emissions. It's highly unlikely that we would decide to cut down an old growth forest to build a wind farm. So that's like a really dangerous assumption that these people kind of buried. And then it's very easy for a news agency or someone on Twitter to just quickly grab that headline and say like, oh, look, we're better off with coal. So that's why it's important to check whatever biases you may have going in and what assumptions you've made.
And then what they're specifically about sensitivity, that's always important to do is like, especially depending, like if you're doing stuff that's like very well established, then it's probably a little bit easier to say like, oh, these are some very detailed point values. But there's a lot of focus now on these like emerging technologies, new processes. So it's with those things, it's a little bit harder to be like, oh, it's going to emit X amount because some of those values you might not know. So it's important to do these sensitivities because then you can go and say, hey, it might not produce 5 grams of CO2, but based on all these sensitivities we've done, we think it's going to be between 2 and 8 grams. And then you can present that information and then someone can say, oh, 2 and 8 is still better. Like even if 8 is the worst case scenario, that's still better than potentially what we're doing now. Okay, then let's move forward. Or you can say, oh, actually 5 is actually the cutoff. What are the things that, like, what are the assumptions that you made that made it get to 8? And then you can figure out and dive down with maybe those are additional details that you need to find out a little more concretely. Maybe those are some assumptions you made that actually, maybe those assumptions aren't actually as valid. And it's important, especially when you go to politics, like so when you go to policy, on like a policy standpoint or even a business standpoint, it's like people, if they know there's a range of outcomes that, and all those range of outcomes is something they're comfortable with, then it's easier for them to like, okay, we can develop policy, we can do whatever we need to make that actually happen.
Outside of policy, though, in the business product environment, you know what those assumptions are because you know how that product or material is being processed. You don't have to make assumptions about old growth forests or any other nonsense. You can literally say, this is how it is getting done. Is that how these analysts are being hired, and is that what they're being used for in industry today? Because I see that there's jobs for life cycle analysts.
Yeah, I think in industry that is like pretty much how it goes. It's
Help make
just-
decisions about where to source.
Yeah.
So it would probably be part of a sourcing organization or a supply chain organization or product design organization.
Yeah.
Okay.
No, I do think that's how they're being used a lot, and that's very nice compared to kind of the more in research, we rely very heavily on collaborators to provide us with that data, and it just very much depends on the collaborator, how much data they're willing to provide and how much assumptions we have to make. And like Chase said, sometimes you just don't know. Sometimes, for instance, they're trying to see, should we even pursue this technology? So we did one about like using new anti-fouling membranes in desalination and how much energy could you maybe save? And these are membranes that haven't been made yet. So we don't have any actual data as to how much fouling they'll reduce. So we had to just assume, let's say they reduce anywhere from like 50 to 80% of the fouling. What difference does it make? And we can say, okay, these membranes are worth it only if you're reducing above 65% of the fouling or something like that. So that's one way that it can be used too. And yeah, another kind of thing to note in this interpretation stage is this like stakeholder power analysis, just to keep in mind, if you're ever reading an LCA or someone has performed one, keeping in mind who like the funding source was, for instance, like, you know, yeah, if someone is saying that coal is better than wind, you should look to see if they were funded by a coal plant or something like that. So just things to keep in mind. So another aspect of life cycle assessment, this field is really growing a lot. And again, there's many different aspects to sustainability, and this kind of conventional LCA covers environmental sustainability pretty well. But there's more work being done now on social life cycle assessment, trying to identify social impacts of different products and organizations. And it has a very similar kind of structure to the environmental analysis, just a kind of different shift in focus. So it will look at things, you know, like if we're building an electric vehicle, what does the mining look like? Where is it happening? What are the regulations there? Is there illegal child labor going on? Things like that, and identifying what are like key parts in the supply chain where there are really high social impacts and things like that. And yeah, the part of this is a social like organization LCA. So even just taking a really high level overview of like an entire company and looking at all of their supply chains and where the hotspots are. So these are some examples. The UN just released its not just, I guess that's a couple of years old now, but their latest guidelines were released in 2020. And these are some examples of stakeholders and different impact categories. So things like, are workers able to unionize? Are they being compensated fairly? Again, is there any like child labor going on? Are local like community values being respected? Are indigenous rights being respected? And yeah, different things like that. So really more of a focus on kind of the impacts on people themselves.
Sorry, I have the question on that slide.
Okay.
Are there any specific metrics that we consider to check the effects on social impacts if there are any changes made in the supply chain?
Yeah, so this one, for instance, might be like a lot of this involves like very different methods than what like an environmental analysis. It might involve like going to a community and interviewing and saying like determining like has quality of life gone up, whether that's based on like level of compensation, level of reported satisfaction or something like that. What I will say though is that this is a very, very like new area. So it does not have the same level of like, here's a model that you can input data in and it will tell you your indicator values. It's very new, and there's a lot of trying to figure out new ways to do it, which is something that is actually later on in this presentation. But yeah.
Who would even put such a model together? It's not going to be Argonne.
Maybe NGOs or
Yeah.
Okay.
people that are looking at
NGOs.
environmental justice. So
Yeah, different like kind of sub-organizations of the UN.
Do you see standards being set for this and somehow some teeth put behind it so that either governments or companies will require a certain standard of social LCA before they'll do business or they'll buy the product or the material?
I think that'd be really useful. I think it'd be, I know, there's a lot of talk about just trying to get sustainability inspired by discussions that we've had with them. And it ties into what Jenna is doing because they're facing a lot of increased threats from mining as the push for electric vehicles becomes stronger. Because if you greenhouse gas emission compare electric vehicles to fossil fuels, it's much better, but we need to be really careful about how we mine these minerals.
Yeah, there's a proposed mine in Minnesota that's within like 2 miles of indigenous reservation. And so, you know, you have land being torn up or animals that they really value and respect might be driven away because their natural habitat is destroyed. And so it's just like an additional step to ensure, you know, like, is this mine really sustainable for everybody, not just on an environmental level, but also like on a human and personal.
There's a big push to do lithium mining in this country.
Yes, in Nevada, and that is also another issue is that I forget what the reservation is called, but in northern Nevada, there is a huge lithium deposit already on federally established indigenous land. And so companies want to come in because it's a very lucrative process. And so like, how do you call that sustainable if, you know, these people have already been oppressed so much and then you want to push them out even further, just so that you can have room for lithium. It's very, very interesting and very, very.
Yeah, I got to go to COP26 where they were studying indigenous inclusion there, and there was a lot of talk about green colonialism and how stripping away people's lands, damaging lands to extract, even if it's for renewable energy, is still tied into this legacy of colonialism. And yeah, I don't think, you know, we can't solve climate change without also solving our like relationships to each other. So
I didn't think you guys would go here. You guys are hardcore chemical engineers. And I'm trying to like, you know, rationalize this in my mind. I didn't think we'd go down the sociological path.
I think it's really important to be whole, like McCormick Engineering is like this whole brain thing, but I think it's really,
I was thinking like a state university. No, this is Northwestern. We're whole brain.
But I think it's really important to be holistically mindset, not just in the sense that electric vehicles are really great for the environment, but the impacts on people. So imagine if that was your family. I don't know.
So are electric vehicles great for the environment, or is it just as bad as gas and
well,
diesel?
I think it depends a lot. Like,
Do you care about the carbon dioxide emissions? Otherwise, electric vehicles are great. But if you're kicking some indigenous communities off of their lands, and you have, and if that's something that's
I gotta do LCA.
what we're doing right now is we're looking at this. We're doing an LCA on the mine in Minnesota that I just mentioned, and we're trying to build these relationships with the Ojibwe communities up there so we can see what they value and what they deem as sustainability so that we can incorporate it beyond just the environmental, like here's how much greenhouse gases are emitted, how much water is consumed, how much energy is required, so that we can make a more holistic.
and there's also
Judgment.
ways to like do mines better than a lot of these proposed mines. And so that's part of it too. Like, yeah, sometimes other LCA people, they're like, oh my God, you Luddites, you hate new technology. And I'm like, no, it's just like, we can't rush into things and risk causing a bigger problem than what we already
That's
have.
the story of humanity.
Yeah.
Yes. And like, again, and in terms of like, yeah, us trying to be whole brain engineers, like chemical engineers have done a lot of damage when it comes to climate change. So.
Mike was off for that, right?
Jennifer knows where I stand. She knew the risk letting me speak. But yeah. So this kind of reflects about, you know, why it's so important to respect Indigenous rights. I wish we didn't have to say this, but it's kind of shocking how often you have to try to argue of why we should respect human rights. But Indigenous peoples are also like, they're sovereign nations. And so I think if you're going to try to say like, you know, they kind of have a right to say, this is how we define sustainability. And it shouldn't be this notion of just one group of scientists or something trying to project onto them what sustainability is. Nice. So this community engaged LCA is especially needed when Indigenous lands and rights are involved, and it involves this blending of what's considered like scientific knowledge using the data, the process models, projections and demand, things like that, along with traditional knowledge that comes first and foremost from building these relationships and, this traditional knowledge is based off of thousands of years of observation and experience right on the ground. And what's also really useful about it is it's very adaptable, like this traditional knowledge, because it's based on experience. We don't have to rely on like just climate models that are trying to predict what's going to happen. People who are living really directly with the land know what's happening in real time. Okay, so this is kind of the general process defined in the ISO and as defined by the UN. So then we're just going to make some changes. First of all, being that the new kind of first step in this is relationship building, really trying to not just extract knowledge, but forge these relationships, understand values, and really build trust, because obviously there is a lot of history to try to overcome here. And even Northwestern doesn't always have the best reputation, so we really have to try to do better.
I didn't hear that.
You got it. And so adjusting the LCA practice, then each step is going to kind of require a shift in like our usual paradigm. So understanding that now you're not just looking at like environmental impacts as separate from human impacts. You're considering all relatives, all species, and seeing how do those environmental impacts tie into the well-being of all the relationships that kind of tie ecosystems together. And something that also comes a lot is, very forward-thinking focus. So the Ojibwe often, and actually several indigenous groups refer to like the 7th generation mindset, that whatever we do now should be sustainable 7 generations into the future. So now looking at how do we incorporate that kind of timescale into life cycle analysis, things like that. So how we're starting to do this, like I said, we're really at the beginning, kind of still in this relationship building stage, and just trying to be like, here are our thoughts, like, what do you think? And kind of what we've learned so far is that relationships need to be at the center of this, not like both our relationships as researchers and collaborators, and also those kind of ecosystem relationships I talked about. As Jenna kind of referenced, environmental LCA is working right now on improving how it addresses biodiversity, but that's an area where it's a bit weaker because it's very easy to quantify, or relatively easy to quantify emissions. It's a lot harder to quantify what happens to biodiversity when we alter the land. And so this is kind of the framework that we've come up with so far, working with our collaborators. So the Ojibwe believe have this worldview of the 4 orders: the physical, plant, animal, and human world. And something we're kind of thinking of doing is taking really key representative species from each of these orders and viewing, conducting an LCA based on their relationships. So saying, how strong are those relationships now? How strong are they supposed to be, ideally, as a baseline? What are the threats? And kind of, if we have something like a mine coming, how is it going to affect those relationships? So for instance, this proposed mine is slated to destroy about 5,000 acres of pristine wetland. And there's many different species within that wetland, and how is that going to affect their relationships? And yeah, it's like that. So that's kind of our little spiel. We're happy to take more questions.
All right, thank you. Any questions, guys?
Have you seen any application of the social LCA so far as compared to the product LCA that we have done?
Yeah, there have been social LCA studies. Jennifer worked with Sarah Young, who's an anthropology professor here, to do, I think it was in the DRC, right?
Yeah.
To do a social LCA of a cobalt mine in the DRC. And one of their main takeaways from that was it's very difficult to do a social LCA right now. And so it really is pretty brand new as a field. And so, but people are working on it. So they had a researcher go there and observe the conditions, interview employees, interview, at all levels of the organization, interview the people doing the actual mining, observing about what the conditions were like, and interviewing members of the surrounding community, things like
for like companies who try to lower their or improve their ESG score. Let's say pick which projects to pursue, maybe discuss with suppliers or buy carbon footprints, whatever. Is this what they do? Like internally they would conduct an LCA or like I would, or is that out of
They
the
should be
scope?
doing.
Yeah.
Yeah.
There's like, I think there's a, like an emergence, I think maybe a little bit more now, people having like else internal LCA teams and stuff that do internal reviews of, life cycle assessments of various products and think, potential ways it can go. Mention a circular economy, so there's things down where like basically building, it's called circularity indicators, so basically quantifying on a circular basis how circular a particular process or product is. And then it's just a matter of some companies and some people kind of aggregate all those things separately. So you might get like an environmental score, social score, economic score, or circularity score. And then you can evaluate each of those kind of separately versus some people. And there's some studies where they basically aggregate everything into like a single number, which has its pros and cons, being like the con being it's a little bit harder to interpret why something might be better than the other, but then it's easier to like, trying to convince a stakeholder, like, hey, here's 5 different products, here's 5 numbers, or here's for what is most, based on these different categories and different criteria, might be a little bit easier to quantify and understand why one might be better than the other. So it's just a difference of trying to understand which and why one might, which way one might go.
As somebody who's done a lot of portfolio analysis and portfolio management, we used to look at things like ROI or risk to the company or time to market or competitiveness. But this is a whole new dimension in terms of the impact on the environment, the impact on the world. And if you can start quantifying it, it makes it a whole lot easier to put it on a scale when comparing one product to another or one product within the whole portfolio. My one beef with all this is it seems like it's opened up a Pandora's box of all sorts of misinformation, partial information, stories that have been twisted to meet some, maybe it's the oil companies who want to trash the electric vehicle industry or something, but I've seen a whole lot of misinformation out there and it's really disturbing. How do you separate it all?
I think I think good researchers know that you need to make your assumptions like abundantly clear. So I know like all of us when we're trying to write papers, it's like, here is our result, but like, don't forget, we did not look at this, like neon sign, this was not included. And I think if you're ever like reading an article that's not doing that, that should be a red flag that maybe there's something buried in supplemental information. I think also maybe even I don't know how, like a big issue is you might have researchers making it very clear what their assumptions are, but if that is taken into just like a little news summary or something that doesn't give everything, it puts a lot of onus on the reader to try to do more digging. And if we could somehow I think it'd be really useful for maybe whoever is writing these kind of articles or like science communication articles to know that with LCA, it's not just about the results. A huge part of it is what assumptions went in, and those have to be reported with the results.
I think it also comes down to something I mentioned earlier about using credible data sources that you can, like Maggie said, outline your assumptions, but also, be really specific and transparent about your data sources. So that people can reproduce should they wish, or they could be like, oh, I see where you got your number and it's from a national laboratory. Like, I feel like I could trust that. So I think it's very complex, but I think just being the most transparent as a researcher you can be really helps eliminate some of that misinformation, or at least makes people feel a little bit better.
Yeah. So like, I know that like the ESG has like 3 scope, and a lot of people and companies have trouble assessing the scope 3 since it's like the client and like accountants. And so from your point of view, what's like the best way to approach like scope 3 life cycle analysis, if that's even a thing? Because it's like it's in the gray area, right? Like how do you assess something that like is not even part of your company, but you're working directly with them and you have to report them also?
I frankly don't know too much about ESG because I've focused many years on LCA. I know that they are related. I think perhaps, I don't know if this fully answers your question, but just having, trying to think, maybe the social aspect of it, kind of looking at the transparency, or do you mind,
Let's-
Jason, Maggie, do you have?
I'm also not very familiar unless you know like what is included in scope
Yeah.
3 of ESG.
So, sorry,
No, it's
my
okay.
bad. So like I think scope 3 includes like emission that is related to your distributor, your supplier, your customer. So any third party that you are involved, so any stakeholder you work with or someone who produce certain part for your product, right? So I feel like that's
Someone that produces for you is.
No, scope one's what's necessary to influence your business.
yeah. So
Scope 3
3 is,
would be your gate to cradle.
yeah,
How do you really track down those numbers and I guess
yeah.
maybe
that's-
solidify those?
Solidify those, because it's like so far removed from your core production that like maybe
Well,
that's,
that could be really where
Escape.
like
It's a gray area.
industry, academia collaborations are helpful because I mean, there's a lot of LCA researchers looking for projects and like working on
We're looking
things.
for data too. Yeah.
But, and I think it's hopefully as this is becoming more and more common, it can even be like, okay, you're working with this group that's like totally outside really of your company, but now they also have LCA people and like their LCA people can talk to your LCA people, like if it becomes that big.
Yeah, I think it's like even if they're outside of your company or, but they have particular things that you know that they're doing, like particular methods or particular activities that, you know, maybe is not, maybe not what you're doing directly, but it's like, you know, kind of like what those activities are. And then kind of potentially figure out, okay, they're doing these things. These things potentially have this X amount of impact. And then add that on, it's like a potential, like, okay, here's scope, you could do the LCA and such that like, here's a scope 1 impacts, here's a scope 2 impact and add it on, and then here's a potential scope 3 impact based on the activities that we know are taking place with our distributors or consumers and things, take into account, consumer habits and things like that, so.
So we know like environmental LCAs have pretty good standards and methodologies, right? Because of thanks to ISO 14040. What do you think are some of the biggest challenges to get to a standards or methodologies for social LCAs? Or is that, I'm assuming it's going to forever be a case by case basis, but do you think there's some hurdles to get some sort of outline or methodology to kind of standardize?
I think
System?
one of the biggest hurdles is just data information. People collecting data on employment or satisfaction or, community health or things that communities value. And so just having that data so you can, look at it and see what patterns to potentially even create a standard. So just even having that comparison, I feel like part of it is a data availability limitation. And then, like you said, it is like a case by case thing, almost that like different communities value different things or different working conditions or different political regulations that make it really challenging. I think something could happen in the future, but personally, I haven't thought of it.
Do you see like a standard, like you have to have community input of this percentage of surrounding population or anything like that, I guess, when it comes to actually trying to get data?
I think I could see a standard like that. I mean, we kind of have things like that with our permitting processes. You have to give X amount of time for community input, things like that. It could very much be like that for doing LCAs. I think, it'd be nice to have a standard, but also there is like richness in diversity and including schools of thought. So I think it's important that if there is a standard developed, I think one potential site for that to happen would be at like the UN, just thinking of like where are large amounts of people meeting. But like the UN still excludes a whole lot of voices, a lot of indigenous voices too. And so it's really important that you have different ideas about sustainability, like coming to the table, because right now there's a huge focus of like, how do we get more electric cars? But that might be the entirely wrong question. Like the question might really be, how do we design like our cities, our lifestyles so that we don't need as many cars in the first place? And so it's like a whole different, that's why it's so important to have different definitions of sustainability. And it's just important that those conversations are inclusive. You like, so it's like maybe someday we'll have a standard, but also I don't think we should wait for that or think that like the standard is the most important thing.
There's been movement in this direction. There's something called fair trade standards.
Yeah.
Right, and those deal with some of the labor issues. Just, practices in terms of working with intermediaries and climate, small scale producers, hired labor, all sorts of, there's different aspects to it. And you can see it when you go shopping at Whole Foods, right? They got the fair trade label on certain products. So I think there's been movement in this direction. I just think that nobody's looked at it as holistically as you guys have alluded to here.
And it's, an environmental LCA is only where it's at because of like decades of research. And so it just is going to take time, but frustrating. Climate change is now. But I think it's worth it to make sure that when we do it, it's done right.
What I foresee is whether it's environmental or, economic or whatever aspect of LCA you want to look at, social, it's going to have a flow down. So when you have a prime integrator like an IBM, they're going to, flow it down contractually to their suppliers and ultimately to their suppliers and their supply. It'll go from the top of the tree to the bottom. And I can see that happening because we saw it happening with certain, financial regulations, right? Once you have a country or a zone like Eurozone go in this direction, the rest of the world will likely follow over time. I mean, it's not going to happen overnight.
Go ahead.
Go ahead, Reza.
Okay, so I'm like a newbie here, so what is like the applications of LCA in the industry? So for example, like you mentioned, a company wants to mine lithium. Where does this aid in the making business decisions?
Yeah, so like, for instance, if you had, so I used to work in like oil and gas, right? So like, if you're working at a refinery and you're trying to develop a new reactor, like you have two new reactors or multiple reactors that are being developed, or multiple processes that are being developed now produce the diesel. Because the way that you're currently doing, maybe economically now it doesn't make sense. Maybe it takes too much energy. Maybe the new technologies that are being advanced. Yeah, like there's just a lot more better options now available to now do it. So you might have people that there's three different processes that are being proposed. You have people that will do LCAs on each of those processes. So from an environmental LCA, what's the differences in energy consumption or the amount of fuel or natural gas that you maybe need for like heat are different, et cetera, et cetera. I mean, couple a lot of times with LCA with TEA, techno economic impact. So now on which one economically is costing, there's one costing more, like maybe it uses less energy, but uses more expensive material for you to use it because you may be of just the type of material that you need in order to get specific energy output. So you would then like be able to take multiple processes and then you can now, okay, here's what the environmental impact is, here's the economic impact, here's what the social impact is. And then you can see, okay, here's the differences between these three technologies. So all of them make more money, but this one has 30% greenhouse less GHG emissions compared to like 10% with the other ones. Okay, now this one makes a lot more sense now on not just on an economic basis, but also on an environmental basis. Or this one, we're able to get the same amount of energy, but we're able to also use like waste streams also. So maybe we can also, in addition to using input streams, we're also able to use like recycled plastics as another fuel source. It's like, okay, now with that being captured in the LCA, that's like another benefit that this technology might have that another technology might. So from
Comparing processes, comparing different products you might be bringing out, comparing suppliers, right? Comparing new materials versus the old. So anytime you're looking at a replacement or a new augmentation to your product or business model, it would make sense to do the LCA.
Yeah, this question was more for consumer goods. I just want to know your perspective that do you think we are able to influence the purchase decision of consumer based on the sustainability initiatives taken by company yet?
I think so. I think we're seeing like there's a big push now in like the perceived value of things going up with their sustainability. And I think consumers would really love a standard. So that's where that's helpful. But I know you remember, I also like interned at Exxon, and right when I was leaving, there was some big thing where the like shareholders said, like, we want like a pledge to reduce emissions, like we want something like that. I can't remember exactly.
No, I don't remember what the number was, but I think it was
Yeah, and this was like a really big moment where all of a sudden, because a lot of times oil companies like, well, we're beholden to our shareholders, so we can't do anything, but now suddenly you have shareholders demanding sustainability. So I think consumers too are really interested in that.
That came from the divesting movement, right,
Mhm.
which have been happening for the last 10 years. So it seems quite odd that the Exxons of the world are embracing this perhaps ahead of other industries.
But yeah, I think it's just like a matter because there's gonna be a bigger push in just, from stakeholders, from just consumers in general, wanting to not have things but have better environmental impacts. It's gonna force companies and stuff to now be able to not only, they have to do the studies themselves, also to prove that this is in addition to all the benefits from this product you're already getting, this is now also good for the planet. And as a result, I think will influence like how, like if something is, two things are the same in price or similar in price, but someone can prove that this is also much better than for the environment, or even some people might even pay a slight premium if they know this is a dramatic impact to the environment versus a product that doesn't have that benefit.
Technology also but technology also for better or worse, like there's huge amount of information available, some of it misinformation, but I think, if it's like, let's say it comes out like, oh, like this electric car maker is using batteries from a place that uses minerals that were like mined under really bad conditions with lots of illegal child labor. Like, I think you're going to see where consumers care about that. I think they've always cared about that. It's just that information now is suddenly becoming a lot more accessible.
Even when Apple was accused of child labor, you saw how quickly that hit the press and how quickly they reacted to make sure that their supply chain was clean. So I think there's a lot more than we realize. I think this does impact consumer behavior. You buy 5 quarts of synthetic oil, there's a brand called Pennzoil. You can get it on the shelves of Walmart and it'll say right on the label, at the front of the label in huge letters, synthesized from natural gas, a cleaner process, right? So, whether an LCA was done, whether it's just marketing, fluff, who knows, right?
Yeah.
But I'm sure I'm one of them. I bought that product instead of the one next to it, right?
Yeah.
So maybe I'm a sucker, I don't know, but I didn't see an LCA, but I saw at least one company saying this is important, right? Any other questions? All right, well, thank you very much. Nice job. You get a picture, you got a picture there, but let's take a picture of us. Yes, that's pretty soon, 6 or 6:30? 6:30, you got some time.
Here?
No,
Nice to.
or remote today.
A remote today? Nice.
Let's do this picture.